Hello, welcome to my channel, the Math Mentor Anuja ma'am. From today onwards, we'll be starting our syllabus of grade 10 CBSE mathematics. So let's start with the first chapter itself, named Real Numbers. Okay, so let's start with our first chapter, Real Number. These are the topics that will be covered in this particular chapter. The first topic that we will cover is real number tree. We'll just understand how the numbers are having their position in this tree. Then we will understand basically we will revise grade 9 knowledge of rational and irrational number. Then we will go ahead with the first concept of this chapter, that is fundamental theorem of arithmetic, very interesting theorem. And then we will see LCM and HCF. Now you will ask me that why LCM and HCF, we have done this in previous grade, but yes, we need to understand because these two concepts we will link, because we have the next concept as HCF and LCM, and we have to see the relationship between them. Okay, so let's start with the topic. So let's start with the first concept, that is real number tree diagram. In this, we have got real number. There are two branches of real number, rational number and irrational number. Then under rational number, we have got fractions and then we got integers. Integers are further bifurcated into three types: negative numbers, zero, and natural numbers. We all have seen these number like natural number, zero, negative number, integer, fractions in our lower grades. Grade 9, we have studied rational number and irrational number. Now let us understand why the real numbers are useful. Real numbers, actually this particular T diagram is useful in getting various MCQs answers as well as to understand the characteristics of a number. So let us start the way they are denoted. So real numbers are basically denoted by capital letter R. Rational numbers are denoted by Q. Irrational numbers are denoted by Q dash. Integers, you all know it, they are denoted by Z. Then zero, like if you have whole numbers, the whole numbers are denoted by W, and the natural numbers are denoted by capital letter N. You should remember these letters because these letters are very useful in your upcoming grade 11 and 12, also in grade 10. So remember these letters. So these are the various bifurcations of the real number. You have to remember this rational number side. Okay, irrational number, there is no bifurcation. So rational numbers are having sub numbers are integers, their sub numbers are negative numbers, zero, and natural number. They are coming on a number line. I hope you know this number line where you have zero, here you have all positive number, and here you have all negative numbers. So this entire arm is a integer. Okay, so this is it, the first concept, that is real number T diagram. Okay, so now we'll start with the revision of grade 9, wherein the basic two arms of real numbers, that is rational number and irrational number. So this particular thing is going to tell you how to understand whether the given number is rational number or irrational number. There are only two ways. First is by definition and another is by writing the decimal number representation. So let us start firstly with rational number. Rational numbers are the numbers. They can be represented by the form P by Q, like sum numerator upon denominator. Denominator should not be equal to 0. For example, 1 by 3. Okay, where see this denominator is not equal to 0. That is one rule. And another rule, these two numbers, like you have 1, you have 3, that is P and Q. They should be co-prime. What is the word co-prime means? Let us understand co-prime. So if I take 1, 1 can be written as 1 into 1, and 3, it can be written as 1 into 3. So you can see here both the numbers are having one common factor, that is 1. See, such two numbers whose one common factor is 1 always are called as co-prime. Okay, remember this. This definition we will require in one of the very important question of this year. Okay, so the two things, that it can be written in the form P by Q. Q should not be equal to 0 and P and Q should be co-prime. Co-prime means what? One of its factor should be always 1. So now let us start with the next definition of rational number, where we are going to deal decimal number representation. Now for that decimal number representation, let us understand What do you mean by terminating, non-terminating and recurring? As the word says, recurring means what? It is going to recur again and again, again and again. So I'll take the example of 1 by 3. If I get the decimal of this, it is 0.333 dot dot dot. So see, you can see 3 is recurring again, right? So I can write this as 0.3 bar, right? So this is a rational number because it is non-terminating and recurring. Always remember, decimal number representation of rational number will always be either terminating or not terminating and recurring. Okay. Now terminating means what? If I take 1 by 2, I know what is the decimal number representation? 0.5. So it terminates. Okay. So if it is terminating, then it is a rational number. Remember this. I hope you have understood. Let us go for the next part where we have to see irrational number. Unlike this rational number, irrational numbers cannot be written in P by Q form. Remember this. And in the decimal number representation, there are two things, that is, they are non-terminating and non-recurring. Always remember, for irrational number, we have always got this word non. Do not get confused with this. Many of the students get confused with these two. Okay. Irrational numbers will always have word non-terminating and non-recurring. What do you mean by that? Let us understand. So if you have a number 0.01, 001, 0001, 00001, you can see, and dot dot dot. Okay, you can see here it is non-terminating and recurring is not happening. Repetition हो ही नहीं रहा है. It is just changing. एक प्लेस पे 0 है, एक प्लेस पे 2 0 है, एक प्लेस पे 3 0 है. So repetition नहीं हो रहा है. That is non-recurring. And it is also non-terminating. So this type of number is called as irrational number. As well as we have got irrational number like root 2, we have got root 3, then pi. This you have studied last year. Pi is an irrational number. Why? Tell me. Why pi is an irrational number? Because in pi, pi we have got 3.14151 value and another value is 22 by 7. Okay, you can see this is P by Q form. That means it is a rational number. Then why are you saying this as a irrational number? This should be your doubt. See, when I do this 22 by 7, it goes on recurring, non-terminating, recurring nahi. It goes on non-terminating way, 3.1415272829, all that things. So for our calculation use, we have taken short form like 3.1415 इसका शॉर्ट कर दिया है, सो दैट हम लोग इसका कैलकुलेशन कर सके फिजिक्स, केमिस्ट्री एंड मैथमेटिक्स में. दैट इज व्हाई एज इफ यू सी द वैल्यू ऑफ 22 by 7, it is non-terminating and non-recurring. Therefore, it is called as irrational number, and for our convenience, we have taken this as approximate value to get the calculation of pi in various formulas. Okay, I hope you have understood this. That is irrational number and rational number. You have to remember these conditions because this we will need it in our exercise. Okay, so for example, I'll just give one example of rational number, that is 1 by 3. I'll give one example of irrational number. Pi is there, root 2 is there, root 3 is there, root 7, many are there. This you have done last year. That is on the number line also. How do we represent root 3 on number line, root 7 on number line? This is just a basic revision. Let us start with our next topic now. Okay. So let us start the next topic, that is the fundamental theorem of arithmetic. We'll read this theorem first and then we'll bifurcate the statement of this theorem one by one and we'll understand this. Okay. Let us start. Every composite number can be written as a product of powers of primes, and this factorization is unique apart from the order in which they occur. बहुत ही ज्यादा डिफिकल्ट स्टेटमेंट है और बहुत ही ज्यादा कॉम्प्लिकेटेड है, तो पहले तो हम लोग इसको बाइफरगेट करेंगे. लेट अस अंडरस्टैंड व्हाट डू यू मीन बाय कंपोजिट नंबर फर्स्ट and we'll understand what do you mean by prime number. If you understand these two, and then we can connect the entire theorem. So let us understand first what is a composite number. There is a slight difference between them, composite numbers and prime numbers. Okay, write it down. This you have done in your lower grades. It is just a simple revision that we are going to do. Prime numbers will have exactly two factors. It will have exactly two factors. The way I've told in our previous topic that if it is 2, I can write it as 2 into 1 only. There is no other factors. Then we'll see 3, it is 3 into 1. So prime numbers basically will have only two factors. दो से ऊपर इसके फैक्टर्स गिरेंगे ही नहीं, ऐसे नंबर को बोलेंगे प्राइम नंबर. ओके, ये हम लोग ने किया है. अभी हम लोग करेंगे व्हाट इज अ कंपोजिट नंबर. इट इज अगेन फ्रेश रिवीजन. लेट अस टेक नंबर 6. तो आई नो 6, 2 एक फैक्टर है, 3 एक फैक्टर है, 6 भी एक फैक्टर है और 1 भी एक फैक्टर है. तो इसमें देखो कितने आगे फैक्टर्स, 2, 3, 6, 1. दैट मीन्स मोर देन 2. Numbers which are having factors more than 2, they are called as composite number. One more example, we'll take 4. 4 I can write it as 2, then 4, then also 1. So it is more than 2. That means 4 is also a composite number. So now how you will use this? But after understanding this composite number and prime number, the line between these two, remember this, prime number exactly 2 फैक्टर होगा और कंपोजिट नंबर मोर देन 2 फैक्टर होगा. अभी हम लोग थोड़ा करेंगे रिवीजन फैक्टराइजेशन का. ये भी हमें लगेगा क्योंकि ये अगर रिवाइज हो गया तो आपको समझेगा कि ये थियरम एग्जैक्टली व्हाट इट इज ट्राइंग टू टेल अस. ओके, लेट अस टेक वन नंबर that is 24. We'll try to factorize this number. Okay, so it is gone by 2, so 12, 2, so 6, 2, so 3, and 3, 3, 1. So I can write 24 as 2 into 2 into 2 into 3 into 1. That means it is 2 cube into 3 into 1. So it's a composite number. Got it? So what we are doing here, every composite number can be written as the product of powers. Can you see? Product of powers of the prime. You can see here it is the prime number 2, 3, 1. They are prime numbers. We are taking product of them. Also the power of these numbers. Okay. And this factorization is unique. हर एक नंबर का एक अपना फैक्टराइजेशन यूनिक होगा, वो किसी के साथ रिपीट नहीं होगा. ओके, apart from the order it occurs. Now let us understand the last line, apart from the order in which they occur. So let us take one number 15. I'll try to factorize this as 3 5s are 5 1s are. I can also do this as 5 first, then 3 3 and 1. So you do either 3, you will get 3 into 5 15, or you start with 5, you will get 3 into 5 15. So order will not be having an impact of that. Okay, so now let us understand, connect all these points together: composite number, prime, the product, the factorization, the powers, and repeating. And let us understand the fundamental theorem of arithmetic again. Every composite number where the factors are more than 2 can be written as a product of powers of the primes, and this factorization is unique apart from the order in which they occur. Okay, so why I am telling you, because nowadays the students are asked with the assertion and reason problem. They put this statement and by mistakenly they change, they do what, you know, they change this, prime को इधर लेके जाएंगे, composite को इधर लेके आएंगे, नहीं तो लास्ट स्टेटमेंट चेंज करेंगे, अपार्ट फ्रॉम द ऑर्डर नहीं लिखेंगे, ऑर्डर इज वेरी इंपॉर्टेंट ऐसे लिखेंगे. सो कुछ भी चेंजेस करके दिस स्टेटमेंट दे चेंज. सो यू शुड रिमेंबर दिस स्टेटमेंट लॉजिकली, डू नॉट रट्टोफाई इट, रिमेंबर दिस लॉजिकली. सो असर्शन एंड रीजन बेस्ड जो क्वेश्चन है, इसके लिए ये कंसेप्ट वाइज समझा तो इजी जाता है, और उसके बाद रीजन देंगे, कोई भी नंबर देंगे और उसका फैक्टराइजेशन देंगे और बोलेंगे अभी A B C D में से option select करो. So this is why you should remember this fundamental theorem of arithmetic. I hope you have understood this. Now let us go to the last topic of our chapter, that is LCM, HCF and relation between them. Okay, now let us start with our last concept or last topic of this chapter, that is LCM, HCF and relationship between LCF, HCF and one small note. So let us start first of all with LCM and HCF. Okay, as I have written, HCF is take only one common number, and then LCM you will take one common number, along with that you will take the left out numbers also. Okay, so let us take one example of number, let's take 15 and 18. Okay, so first thing that I will do, I will prime factorize 15, that is 3 5s are 5 1s are. I'll do 18, 18 2 9s are 3 3s are 1, right? So if I have to write 15, it is 3 into 5, and 18 I can write it as 2 into 3 into 3. That's it. Okay, so now if I have to do HCF of this, what I have written? I have written take only one common, only the things which are common. So look at this, which two numbers are common? I can see 3 is there and 3 is there, right? So the HCF is 3, nothing else is common. So HCF is 3. Now let us see LCM. LCM again, take common number along with the left out numbers. So common number is 3, we know, and left out number from first number is 5. Next number it is 2, and then it is 3. So if you multiply this, how much you will get? 15, 15 2s are 30 and 33s are 90. So you get LCM as 90. Okay, so you can see that this HCF is a factor of LCM, and that is why I have written this note. HCF is always a factor of LCM of two numbers. Remember this note. Again, very small puzzling MCQs can be asked on this note, because this is done in your earlier class, lower class. You should remember HCF हमेशा एक ऐसा number होता है कि जो factor होता है LCM का. Remember this. So this is the fast revision of LCM and HCF. Let us understand the relationship between HCF and LCM. If you have got two numbers A and B, then HCF of A and B into LCM of A and B will be equal to product of A and B. Let us understand this with one sum. I am taking two numbers, one number is 12, another number is 9. Okay, I am going to see this relation, check this relation. First of all, I'll factorize 12. So 12, 6 are, 3 are, 3 are 1. Okay, and 9, 3, 3 are 1. So I can write 12 as 2 into 2 into 3 and 9 as 3 into 3. Okay, so tell me what is the HCF of this? HCF will be only one number because it is there, one common number, that is 3. Okay, and if I have to take LCM, it will be 3 which is there, and left out 2 into 3. So if I multiply this, I'll get here 6, 6 6 are 36. Okay, now let us check this relationship with these two. Okay, now what I've said, HCF into LCM is equal to product of the number of the numbers. Okay, so product of the number is 12 into 9, because we are taking these two numbers. So 12 into 9, I know it is 108, right? So our RHS is already verified. Let us see LCM and HCF product. HCF is 3 and LCF is 36. Let us see whether it is coming 108. Yes, it is also coming 108. So it is verified. Okay. I hope you have understood whatever I have taught you today. Today we have completed the concept, all the basic concept of the chapter real number. where we have seen real number tree diagram, then we have seen rational irrational number, fundamental theorem of arithmetic, we have also seen LCM, HCF and relationship between them. In our next class, that is my next video, I'll be teaching you the concept, that is very small concept of very small theorem which is important for solving the sum, as well as we'll be saying relationship between HCF and LCF and the three numbers relationship between that. Okay, so we'll check that in our next video. If you have got any doubt, any query, you can write it in comment box. Please do like, share and subscribe to my channel. Bye.